Welcome. What I'd like to do is show you how to apply the Pythagorean theorem when given a triangle like this, and we know it's a right angle. So the first thing I want to do is identify what is the hypothenuse. So I draw a nice little line across from my right angle, and I can identify this is my hypothenuse. Now, you could use either formula. We can label the hypotenuse as c squared, the two legs as a and b, or use this formula to go ahead and solve. Now, I know it's fractions, but that's OK. We're just going to plug it into our formula. So our missing length, I'll put an x right there. So therefore, I'm going to want to take the sum of these two legs squared and set it equal to my hypotenuse squared. So I'll say 1/8 squared plus x squared equals 3/8 squared. Now, when squaring a fraction, a over b squared, and let's use different variables. Let's use m over n. Remember, when you square a fraction, you square the numerator and the denominator. The squaring distributes to both the numerator and denominator. So therefore, this is going to be 1/64 plus x squared equals 9/64. Now, I need to solve for x squared, so I'll subtract 1/64 on both sides. And therefore, I get x squared equals 9/64 minus 1/64. Since these both have the same denominator, that's good. I can just subtract across. So therefore, that's going to be 8/64. Now, to solve for x, I take the square root, take the square root of both sides. X equals, now I need to, again, just like the squaring distributes, the square root distributes as well over division. So therefore, I need to take the square root of 8, which I cannot take the square root of 8 evenly, but I can break that down into the square root of 4 times 2 over square root of 64 is 8. And the reason why I broke that up is I broke it up into a square number, right? The largest square number that divides into 8 is 4. And now I can take the square root of 4, which is 2, still have a 2 inside the radical, divided by 8. So there you go, ladies and gentlemen. That is how you solve for your missing length using Pythagorean theorem. Thanks.